In this video, we're going to go over the initial value problem. Initial value problems typically consist of a differential equation along with an initial condition where your job is to find the particular solution to the antiderivative. In this question, it says to find the function p of t knowing that dp over dt is equal to 25.3 multiplied by t to the power of 4 and p at 0 was equal to 12. This right here is our initial condition where we know when t was equal to 0, our output p was equal to 12. Here we have our differential equation, which we can call p prime of t. And in order to find our antiderivative p of t, we can take the integral of this. And so we can say p of t is equal to the indefinite integral of 25.3 t to the power of 4 dt. I now notice that I have a constant inside of my integral, which I can simply take and pull out to the front. This is equal to 25.3 multiplied by the indefinite integral of t to the power of 4 dt. I can now use a simple power rule for integration and add 1 to the exponent and divide by that exponent. And so what I'm going to get is 25.3 multiplied by t to the power of 5 divided by 5. And don't forget your constant of integration plus c. I can now divide 25.3 by 5 and reduce this down to 5.06 t to the power of 5 plus c. We now found our antiderivative, but this is just a general solution. We want to find the particular solution given our initial condition. So in order to do that, we can use this piece of information right here. We can say that p at 0 was equal to 12, and everywhere I see a t, I'm going to plug in a 0, and I'm going to solve for c. So I can say 5.06 multiplied by 0 to the power of 5 plus c. And so I'm going to get 12 is equal to c. And so therefore we can say the particular solution to this initial value problem is p of t is equal to 5.06 t to the power of 5 plus 12. And just to double check your work, you can always go ahead and replug in t equals 0 into the particular solution you just solved for, and it should equal 12. If it equals 12, that means you did everything properly. In this next question, we're told to find the function f of x knowing that f prime of x is equal to 4 over x, where x is less than 7, and f at negative 2 is equal to 4. I'm going to go ahead and rewrite this as 4x to the negative 1, so I can find its antiderivative more easily. And then we have our initial condition over here, which is saying when x is equal to negative 2, our y value must have been 4. And we're told to find the antiderivative f of x. So this is going to be equal to the indefinite integral of 4x to the negative 1 dx. And don't make the mistake of trying to use power rule of integration, because we have an exponent of negative 1, and this is just one of those antiderivative rules that you just have to memorize. The antiderivative of x to the negative 1 is just ln x. And typically we put an absolute value sign, which represents the most general solution. However, I noticed that in the question, it says that x is less than 0. So I'm going to go ahead and remove the absolute value signs, and I'm going to replace it with negative x. And now we just have to solve for c. We're told that f at negative 2 is equal to 4, so why don't we go ahead and do that. So f at negative 2 is equal to 4, and everywhere I see an x, I'm going to plug in negative 2. So this is going to be 4 multiplied by ln of negative 2, which will just be 2, plus c. And then I'm just going to rearrange. So therefore, this is our c value. And therefore, we can say that the particular solution is f of x is equal to 4 ln minus x plus 4 minus 4 ln 2. And just to double check your work, if you want, you can go ahead and replug in x equals -2 into your particular solution that you just solved for, and it should equal 4. If it equals 4, that means you did everything properly. In question 3, it says to find the function f of x knowing that f prime of x is equal to 7 to the power of x minus 7.7, and f at 3 is equal to 15. This means that when x was equal to 3, our output y was 15. And so this is our differential equation, and we're told to find f of x, which is our antiderivative. So f of x, our antiderivative, is equal to the indefinite integral of 7 to the power of x minus 7.7, all multiplied by dx. And so we can just evaluate this integral now. And so what's the antiderivative of 7 to the x? Well, let's start with 7 to the power of x. If I take the derivative of this, I'm going to get 7 to the power of x multiplied by the derivative of the exponent multiplied by ln of the base. And as you can see here, we do not have ln 7 here. And so to get rid of this ln 7, we'll need to divide by ln 7 here. And so if you take the derivative of this, you're going to go back to here. And then negative 7.7 is just a constant, and whenever you have a constant, you'll just add the variable to the end. And then don't forget your constant of integration plus c. And so now we're going to solve for c. So we know that f at 3 is equal to 15, and everywhere we see an x, we're going to plug in 3. So this will be 7 to the power of 3 over ln 7 minus 7.7 times 3 plus c. And so solving for c, we can simplify this down to 15 equals 343 over ln 7 minus 23.1 plus c. And then isolating for c, I'm going to bring this negative 23.1 to the left side. And so it's going to become 15 plus 23.1, which will be 38.1. And I'm going to bring this to the left side. And this is going to equal c. Therefore, we can say that the particular solution to this initial value problem is 7 to the power of x divided by ln 7 minus 7.7x plus 38.1 minus 343 divided by ln 7. And as always, you can always double check your work by doing the check. So you can go ahead and replug in x equals 3 into the particular solution that you just solved for. And if it equals 15, that means you did everything correctly. In this last example, we have this question where it says to solve the following initial value problem, where we have this differential equation and this initial condition, where when x is equal to pi over 2, our y value is equal to 3. And so to find our antiderivative y of x, we just have to take the integral of this. And so what's the antiderivative of cos? The antiderivative of cos is just sine, and then we have the 2 and the x over 3 like normal, and we'll have to divide by 1 over 3, which is the derivative of the inside. But that's the same thing as saying multiplication by 3. Now you might be wondering, why do we have to do that? That's because if you try to take the derivative of this, you're going to get 2 multiplied by cos of x over 3 multiplied by the derivative of the inside, which will be 1 over 3. And that's also saying division by 3. And so in order to get rid of that 3 in the denominator, because we don't see one here, we have to multiply by this 3 so the 3's cancel out. And so I'm just going to simplify this and multiply that 3 with the 2 out in front. Now we can apply the same logic to this piece as well. So once again, the antiderivative of cos is just sine, and so we'll have 4 sine 3x, and we'll divide by 3. Now you might be wondering why again? Well, it's because if you take the derivative of 4 sine 3x, you're going to get 4 multiplied by cos 3x multiplied by the derivative of the inside. But here, we do not see any multiplication of 3 outside of cos, so we have to divide by this 3 to get rid of this 3. And so don't forget your constant of integration plus c. We can now go ahead and sub in x equals pi over 2. And so pi over 2 divided by 3 is the same thing as saying pi over 2 multiplied by 1 over 3. So I'm just going to change this to pi over 6 plus 4 over 3 sine 3 pi over 2. And don't forget the constant of integration plus c. And so now we know that sine of pi over 6 is just 1 over 2, and sine of 3 pi over 2 is just negative 1. And so we can simplify this to 3 equals 6 times a half, which is just 3. And then this will become minus 4 over 3 plus c. Now solving for c, we're going to get 3 minus 3 plus 4 over 3 is equal to c, and so c is equal to 4 over 3. And so therefore we can say that our particular solution is equal to 6 sine x over 3 plus 4 over 3 sine 3x plus 4 over 3. And this is your particular solution to this initial value problem. And once again, you can do the check where you plug in x equals pi over 2 again, and it should be equal to 3. If it equals 3, that means you did everything properly.